Hello friends, welcome back to the bench. Our patient today is Asus GTX 1060, 6 gigabytes of DDR5 RAM. Bad. It says bad. I got it off eBay, so I trust the technician that tested it and deemed it as faulty. Now, can we fix a GPU? Well, we don't really have the proper equipment for GPU work or proper tools, be it both software and hardware, but that never stopped us before, huh? Let's, I got my little cheat sheet over here, the pinout of PCI Express. So let's check the voltages. So what we can fix are shorts, because they're obvious, right? We just inject, we see what's getting hot, and if it's a cap, if it's a transistor, we replace it. If it's a core, we don't replace it. The other common faults on GPUs are corroded pads under memory chips, faulty memory chips, corroded pads under the core, faulty core, meaning shorted core. These are the faults that we cannot fix because, well, number one, I don't have a stencil for memory chips. I don't have replacement memory chips. And that's pretty much it. The other thing that I'm missing is the ability to run a memory test on the GPU. I'm working on the rig that will be capable of doing that, but it's not quite ready yet. Doesn't matter though. Let's do some measurements. So we're in diode mode, and we are on side A, and let's hook up to the ground. And our pin A2 and A3 are 12 volts. No short and no short. Our standby power 3.3, pin A10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No short. Then side B. And on side B, we have 12 volts on B2 and 3. It should be the same rail, I would expect. This one's fine, and this one's fine. I don't know if you can see the readings here, but you can just trust me. And B10 is our 3.3, so that's this one. Is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. We have nothing on this 3.3. Is that normal? That's interesting, but it could be normal. So this is not a very powerful GPU, so it might be normal that only one 3.3 on side A is connected and side B is not. But we'll check it out. Maybe there's some cracking, although I don't see any. I don't see any cracking, and it's not very heavy GPU, so I wouldn't expect a cracked board. So we're good here. So now the main power rail, which is 12 volts, comes here. And I expect that this is ground and this is 12 volts. We have 400 drop, 1.2 and 400. and this is also ground, and this is also ground. So these three are ground, these three are not. So no shorts here, which is too bad, because again, shorts are one of the very few things that we can check. Now, without opening it, we will have to open it and check on the coils, but without opening it, we don't want to see shorts on these capacitors here. And we do have a short here. So, if this was a shorted transistor, we would likely see the short on the input. On where is it? Here. We would likely see the short over here. There's looks like there's a little bit of damage to the board over here. Is that a crack? No, it's just and this is fine, and yeah, this is fine. So the connection is here. So the board is not damaged. I mean, it's damaged, but it's the connection is not broken. So we know we have a short here somewhere. Now, if we're really lucky, it's going to be one of the caps, but it's very unlikely. I mean, very unlikely. Maybe it's not very unlikely. Like this cap is fine, or this rail over here is fine. Yeah, this was fine. And this is fine. So it's only on these here, right on the core. Yeah, all these are shorted. Yeah, this is all shorted. 0. So if we're lucky, what would have happened to this one is, you remove it. Yeah, these are shorts. You remove it from the computer and you just throw it on the pile of the components that are going to recycling. And then recyclers sell these as faulty, even if they were not faulty when they were removed from the computer. Then you throw them on they are being thrown on the pile, and one of the caps goes short because they're physically damaged. We talked about that quite recently. So if we're lucky, one of these caps will be shorted. Probability of that is low. Here we have a BIOS, win bond. This is probably 128 megabyte BIOS. So maybe we can just rip it and save it. So without further ado, let's dig inside. And actually, before we dig inside, let's check the data lines. Because why not? Because if on top of that data lines are damaged, are faulty, that is gonna be a waste of time. Data lines are good. All LEDs lighting up. So data lines or data lanes are good. Or at least there are no shorts or open lines. All right, let's open it up and see what we're facing inside. So one little thing, as you can see, this has been opened before, judging by the screws, right? So definitely we're not the first ones to open this device. Good to keep that in mind. here are our transistors. So now if the low transistor is shorted, that would explain why we have a short on the capacitors. If the high transistor is shorted, that would not register as short, but if the high transistor is shorted and you connect the GPU, then you essentially send 12 volts to the core. So if this was connected, and I connected it actually, so if the high transistor is shorted, then the core is definitely shorted. So let's check with the beeper first. On this coil, it's fine. This is 30 ohms, so this is fine. Yeah, this is okay. Yeah, we have short on both sides of these, but that doesn't mean it's bad. There's no short on the gate, but this is sitting on the ground. This is not. Yeah, this is not sitting on the ground, and this is sitting on the ground. Which means that either this is low transistor. Yeah, everything on this side is sitting on the ground. All of these. Yeah, every single one. Which is weird. So do I not understand this circuit, or we do have some shorted transistors? No short here, but very low reading. Too low. Same here, but not shorted. This one seems fine. This one seems fine. This is fine. And this is fine. So these transistors seems okay. These are all shorted, but doesn't mean that the transistors are shorted, right? And without the board view, it's gonna be a little tricky, because we don't know how these transistors are connected here. They could be connected in parallel. So these could be low transistors, and this could be high transistors. So 1 for high and 2 for low. It's kind of unusual, but we have 3 transistors per line, right? 1, 2, 3, 4 lines, and 3 transistors per line. So it could be that these transistors open, and these are modulating and pushing energy to the coils, right? One is opening the voltage, the other one is shorting to ground. That's normally how it works, but we don't know in this particular one. Now I still don't know if this is missing transistor, a missing capacitor that has been removed by someone, or is it missing from the factory? Both options are plausible. Which means, what can we do? Well, we're gonna have to inject some voltage and see what's getting hot, because without the board view, it's kinda difficult. But let's see, we have, what is this? This looks like MOSFET. Let's see, the coil to the ground. It's fine. Yeah, all these are fine. I mean, this one is very low, but this is normal when you know, the core has very low resistance, so this low voltage drop is normal here. It's just like few ohms. It's kind of like the same with CPU. 3, maybe 5 ohms. So this would be normal. Okay, so now we're gonna inject 800 millivolts into this rail and see what's getting hot. So our options are, or preferably what we would like to see, is one of these transistors heating up. But the other possibility is that the core is going to start getting warm. Yep, nothing is heating up. Let's see the back side. Nothing's heating up, and we're grabbing 800 milliamps, which means it's gonna be a shorted core. Let's get the light away so we can pinpoint better. But yeah, now we're pushing energy and nothing is lighting up. Which means, what does it mean? That means something is consuming that energy, but it's large enough that it's not going to register as a tiny heat spot. So the only thing that we can do is just increase to 1 volt. That's going to give us more energy, aka more heat. And maybe we'll be able to spot something. 0.9 watts, so that's not a lot, but it's enough for the thermal camera to register. Now you see the core. Yeah, the core is heating up. And there you go. See the core slightly increasing temperature, 36.6. That's body temperature now. 36.8. And our wire is getting warm as well. So the wire is getting warm before anything else. So none of these transistors here is heating up. Well, let's have some fun with this. Okay, just to make sure, I removed all the transistors, right? And we still have a short over here, right? Obviously, I didn't expect anything different, but you never know until you know. See, the gates are fine, meaning there is no short to the gate, but drain source are shorted. But they are shorted because the core is shorted. If it was in a simple issue like shorted capacitor or shorted transistor, this probably wouldn't have been sold as damaged. I mean, it still happens, right? You can find plenty of broken devices on eBay that have simple fixes. Of course it happens, But with GPUs especially, there's so many parts that you can order. Even, plenty of boards with just no core, perfectly working board, but no core. Or at least advertised as. So there's plenty of resources for repairing GPUs, so it's rather unlikely to be able to find a GPU that has simple fix. But it happens. You can definitely find it. So now, since our transistors are disconnected from the coils, we know the issue is on the other side, right? Let's see if we can quickly remove the coils. Okay, so now the driver side is completely disconnected. So if we still have a short over here, that's 100% core. Well, now it's 100% core. I mean, it was 100% core when we injected voltage, and only core is getting warm, nothing else. But in some cases, it could be explained. It's not always the core, but you would see higher resistance. And now let's see. So the short should be gone on this side. Yep. Now the short is gone here because our coil are disconnected. But all this is gonna be. So our core is a piece of wire at this point, and unfortunately it's none of the capacitors on the other side. If it was, we would see a nice little spot. Alright, so this is no fix, unfortunately, but we do have few nice little parts. These are very nice transistors. They are pretty universal. I just need to clean them and designate them whether they're P channel or N channel. But maybe the next GPU will be a success. What I will do later on is I will lift the core. I will remove the core from the board and then check for shorts, meaning completely definitively say that it's the core that it's shorted. But I'm not gonna do it now. It's time to get some breakfast. Too bad this was no fix, but I didn't expect much from this one. I never had much success when it comes to GPUs anyways, and most of the GPUs that you buy are faults like this, not something simple. But from time to time you get a nice piece. You just replace one cap and you have working GPU. Not this one, unfortunately. Alrighty, that'll do for today. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.